You ever get that feeling that numbers have a secret language? One that's hiding all these cool patterns that can make math feel less like a chore and, I don't know, more like a magic trick? Well, today we're going to pull back that curtain on a few of these secrets, and we're going to start with a simple challenge. Okay, right out of the gate, a quick question for you. What's 95 times 95? Go on, take a second. Maybe you're reaching for your phone's calculator, or you're starting to scribble it out the long way.
And the answer is 9025. Yeah, and I'm willing to bet I got there a whole lot faster than you did. But not because I'm some kind of human calculator, nope. It's because I know a secret.
So you want to know the trick? Good, because that's exactly what we're going to dive into. I'm going to show you that trick and a few others that really start to reveal the hidden, beautiful structure of numbers. Okay, so to really get the trick, we first have to look at how squaring normally works, and more importantly, how we can find a better way than that tedious multiplication we all had to learn back in school. So squaring is simple, right? It just means multiplying a number by itself. Super easy for something like 2 or 3, but it gets pretty clumsy with bigger numbers. The good news is, that's not the only way to do it. Not by a long shot.
Let's start with a method that works for any number you throw at it. The best way to think about it is like deconstruction. We're going to take a hard problem and just smash it into a few really easy ones. We call this the breakdown method, and it's exactly what it sounds like. Instead of trying to wrestle a big number all at once, you just split it into friendlier pieces, like tens and ones, and then you multiply those smaller parts out. So let's try it with 39. First step, split it. It becomes 30 and 9. Easy enough. Then you distribute. You take the 30 and multiply it by the whole thing. And then you take the 9 and multiply it by the whole thing. That gives us 4 much simpler multiplication problems to solve. Once you add those all up, you get 1521. See? It's a really clean method that lets you avoid those huge, messy calculations.
Okay, so that breakdown method, it's a fantastic tool to have in your back pocket. But for certain numbers, there's a shortcut that is so fast it feels like actual magic. And this slide right here really shows you the difference. On the left, you've got the breakdown method for squaring 75. It works. It's totally valid. But look at all those steps. Now, look at the right. The same problem solved in just 2 dead simple steps. So how is that even possible? Well, here's the secret. This amazing trick only works for numbers that end in 5. So what you do is you take the first digit, in the case of 75, that's the 7, and you multiply it by the very next number up, which is 8. That gives you 56. Then you literally just stick 25 on the end. 56, 25. You're done. And this brings us right back to our first problem, doesn't it? For 95, you just take the 9, multiply it by the next number, 10, to get 90. Slap a 25 on the end, and you've got your answer, 9025. It's a 2-second trick, just like I promised. So we found some really cool tricks for calculating square numbers. That's awesome. But what does a square number actually look like? It turns out when you start to visualize them, you uncover an even deeper, more incredible pattern. Let's start building out a pattern here, and we'll begin with a really simple number, 3 squared. I want you to think of it not just as a number, but as an actual physical square. Now, what do you think happens if we take the very next square number in line and add it to our first one? So we'll add 4 squared to the mix. Okay, so we all know 3 squared is 9 and 4 squared is 16. If you add those two together, the sum is 25. And what's so special about 25? Well, look at that. It's also a perfect square. It's 5 squared. And believe me, this is no coincidence. What we've just stumbled upon is something called a Pythagorean triplet. It's this special family of 3 whole numbers where the square of the first plus the square of the second is exactly equal to the square of the third. You probably remember this from geometry class, right? It's the rule for right-angled triangles. But how do you find these triplets? Are they just random? No, not at all. There's actually a master formula, a secret code that can generate them for us on demand. And here it is. This is the whole shebang. All you need is any whole number m as long as it's bigger than 1. From that single number, you can generate a perfect triplet using these 3 simple formulas. This is the recipe. So, how do we actually use this thing? Let's put it to the test with a little puzzle. Can we find a triplet that includes the number 12? All right, we can just test our formulas. What if that middle term, m squared minus 1, is our 12? Well, that would mean m squared is 13. And since 13 isn't a perfect square, that's a dead end. Okay, so what if the first term, 2m, is 12? Ah, that means m must be 6. And that works. We found our key. Now that we know m is 6, we just have to plug it into the other formulas. So 2m is 12, obviously. M squared minus 1 is 36 minus 1, which is 35. And m squared plus 1 is 36 plus 1, which is 37. And there it is. Our triplet is 12, 35, and 37. The code worked absolutely perfectly. So we went from a simple squaring trick all the way to a formula that generates these ancient geometric patterns. We've seen that numbers are just full of these elegant, hidden secrets, which, it just makes you wonder what other beautiful patterns are out there, just hiding in plain sight, waiting for us to notice.